Okay, in this module, we're going to be talking about the layers of the earth. And I know you've talked about the layers of the earth before in elementary school, but we're going to go a little deeper with this. So our essential question is, how are the layers of the earth different from one another? And we're going to be looking at standard S6E5A, which says to compare and contrast, so to find the similarities and the differences between the earth's crust, mantle, and core. And we're definitely going to focus on their temperature, the density, and the composition of the crust, mantle, and core. Remember, composition is what it's made of. So we're going to remember that the Earth is made up of three main layers: the crust, the mantle, and the core. But you know the core is divided into an inner and an outer core. And when we look at this diagram, we see that the crust is less than 1% of the Earth's mass. So it's not very thick at all, anywhere from 5 to 100 kilometers. Now, a kilometer is 1,000 meters, and a meter is about the length of a baseball bat. So about 5,000 to 100,000 meters baseball bats thick. That sounds thick, but when you compare it to the rest of the layers, it's very thin because the mantle, which is below the crust, takes up 67% of the mass of the earth. So over 50%, over half of what the earth is, the composition of it is in the mantle. And you can see it is 2,900 kilometers thick. And this was only up to 100 kilometers thick here in the crust. And then we have the core, which is about 33% of the Earth's mass. So about a third of the Earth is made up of the core, and its diameter from one side to the other, because it's the center of the Earth, is about 6,856 kilometers. So if we think of the layers of the Earth like a cake, on top of the cake, if it's a good cake, it has icing. And so that would be like the crust of the Earth. Very thin, just a little bit of layer on top. It's where your toppings are, it's where your decorations are, and that's the way it is. It's on Earth, it's where all the things on Earth set on the crust. Even the ocean is on top of the crust, so the water sets on top of that. And then this is a red velvet layer. We would say that's the mantle. And then you have an outer core, that's the yellow cake here, and the inner core, which would be the white cake. So you'd have the crust, mantle, outer core, and inner core. And this is a foldable that you are working on as I will be discussing these things. You shouldn't have written anything yet unless you labeled those layers there on the outside of your foldable. And remember, yours should be colored at this point. So we're going to start with the very top, which is the crust. This should look exactly like your diagram, and here's where the crust is on the whole piece of pie from the earth here. So here we have the ocean. So this is water sitting on top of the crust, and then we have land sitting on top of the crust. And in this case, the land would be the layers of the soil. So you have two types of crust. You have oceanic crust and you have continental crust. And I would go ahead and label that on your foldable. Label right there. Mine's in pencil, so it's hard to see. But I labeled oceanic crust and continental crust because they're different in the fact that they are made of different rocks and minerals, and they are different thicknesses. So the crust is the thinnest layer of the earth, and in some places it's only 2 miles deep, and then in some other places it goes up to 75 miles deep. Under the mountains is where the crust is going to be the thickest, and on land it's the thickest, which the mountains in most cases are on the land. The oceanic crust is very thin, so it's much thinner than the continental crust. So when we are drilling and trying to get past the crust, which we've never done, scientists have never been able to drill past the crust. So we've not even been to the mantle, the outer core, or the inner core. But when they do try to do that, they always drill in the ocean because it's a lot thinner and easier to reach the mantle. They don't have to drill through so much crust. So oceanic crust is much thinner than your continental crust. And these are things I'm saying, and then things that are written on the slide here are things that you would want to write down inside your flap where it says description. You don't have to write them word for word. You can shorten them into your own words as long as you know what it said when you look at it later. The crust is made up of large amounts of silicon and aluminum. Those are the two main minerals that our crust is made of. And then, already mentioned this, there's two types of crust, the oceanic crust and the continental crust. And the crust is actually not one solid piece. It's broken into lots of pieces, and we call those pieces tectonic plates. And those tectonic plates are what move back and forth and cause the oceans and the continents to move with them very so slightly. So think of the crust like the skin of an apple. It's very thin, and once you get past the crust, there's a lot of stuff underneath it. So the crust on Earth is like the skin of an apple. So below the crust, we have the next layer, which is the mantle. And in the mantle, we have sections. We have the lower mantle, the middle mantle, and that's where we have what's called convection currents. And we're going to talk a lot about convection currents this year. This will be the beginning of convection currents, but we talk about them in the Earth's layers. We talk about them in the atmosphere. We talk about them when we're talking about how heat moves. So we're going to hear a lot, and you're going to hear a lot about convection currents. And then we have the upper mantle. And you might want to label that on your foldable as well. So the mantle is solid, but it can flow a little bit. Think of hot asphalt when they're pouring it to create a road, and how it's ooey and gooey, but it still is able to pour. Or think about when you're making brownies and you make that brownie batter and you pour it into the pan. It's really, really thick. So it can flow a little, but it's a very slow flow. Another way of thinking of it is like syrup that's really cold, and it won't move too much, but if you pour it, it will pour. The mantle is the thickest layer of the Earth. Remember, it made up the majority of the composition of the Earth. It says here about 70% of the Earth's mass. The mantle is very hot. The closer you get to the center of the Earth, the hotter it's going to get. So the mantle has that hot material, which we know is called magma because it's underground. And what happens in convection currents is the center of the Earth, the inner core, is where the heat comes from. And so the lower mantle is going to be a lot hotter than the upper mantle. And that heat comes from below, so it causes the magma here to warm up. Okay, so all the magma here at the bottom warms up, and if you know the rule of science that warm air rises, so do warm liquids, you know that as that magma warms up, it's going to rise to the top of the mantle. Well, once it gets to the top, it's away from the source of the heat, so it's going to start cooling down. And that means it gets heavier, it gets more dense, so it sinks back down. And then more magma is heating up and it rises up. And so what that does is it creates what we call a convection current. And I'm going to talk more about convection currents in class and show you some more demonstrations. But that's what's happening there. So when that's doing that and that magma is flowing in that circular motion, it's causing the tectonic plates that the crust is broken into, these pieces of the crust, to move back and forth ever so slightly, which then causes our events such as earthquakes and volcanoes to occur. So that's what's happening here. So I wrote it here. The hot material in the mantle rises to the top, cools, then sinks, reheats, and rises again. These convection currents causes changes on the Earth's surface. So it'd probably be a good idea to write that down because convection currents is probably a new concept and one that can be complicated. So next we have the core. And the core is made up of an inner and an outer core. Obviously the inner core is going to be on the inside and the outer core is going to be closer to the outside. So here we have our outer core. And now our outer core is all liquid, okay? It is the only layer that is completely liquid, and it's metal. It's made of iron and nickel, but that iron and nickel is so hot that it's melted metal. And it's about 4,700 degrees Celsius, or if you think of it in Fahrenheit, which we're more familiar with, 8,000 degrees Fahrenheit. That's pretty hot. Water boils at 212. 212 degrees. So you can see 8,000 degrees, really hot. The outer core is about 1,800 miles below the crust, so that is a very long way to get to the outer core, and it's about 1,400 miles thick. So you add that together, and you get, let's see, 3,200 miles to get to this point right here, to the bottom of the outer core. That's a long way. So you see why drilling to the center of the earth is kind of a hard thing to figure out how to do. I said this, it's composed of the melted metals, nickel and iron. Then we have the inner core. It's red because it is very hot, mostly made of iron, a little bit of nickel, and it is solid. It is believed to be as hot as 6,000 degrees Celsius, which is 12,000 degrees Fahrenheit. We're getting hotter and hotter. So you can see as you get to the center of the earth, it gets hotter and hotter. And they think that the heat is probably created by the radioactive decay of uranium and other elements is causing that heat to still be happening and heating up that inner core. It's solid. Now, at 12,000 degrees, you would think it would be completely melted iron, okay? But what happens is there's so much pressure there from all those other layers squeezing it that it can't move like a liquid, so it's not a liquid. To be a liquid, something has to be able to flow, and because that is being squeezed so much that it can't flow, so it's considered a solid. They say that if you were to go to the center of the earth, like in the movie, you would actually be squeezed into the size of a marble. Your entire body would have that much pressure on it that you would be the size of a marble. Would you be alive? Of course not at that size. Okay. Next we have, I'm sorry, pause. Okay, I had a visitor at the door, so we lost our place in where we were. So let me jump ahead a little bit. Here we go. So another way of looking at it, take lots of objects that we eat and look at how they compare to the earth. You could say it's like a peach. The outer skin of the peach would be our crust, and then this would be the mantle, the fleshy part, the part that tastes good, and then the pit, the inner part of the peach is really hard. You could say that's the core, especially the inner core, because it is a solid. Or you could say it's like a boiled egg. This boiled egg doesn't seem to have the shell on it still, but the eggshell would be the crust, and then the egg white would be the mantle, and then the yolk would be like the core. Okay, so what's happening here? We have our mantle. Layer the mantle. Remember we have the upper mantle and the middle mantle and the lower mantle. The layer of the mantle that's called the asthenosphere, and that's this word right here, asthenosphere. That's the part that slowly moves back and forth, that kind of oozes. So we call that the asthenosphere. And there's the crust. Now the crust, remember, is solid, and the upper part of the mantle is solid too, and that is called the lithosphere, the hard part of the earth. So that would be the crust, and the upper part of the mantle is the lithosphere. And then the layer of the mantle where it starts to ooze and get hot and liquidy is the asthenosphere. Practice saying that one. Here's another view. The asthenosphere is the soft layer of the mantle in which the pieces of the lithosphere move. So that's what oozes that allows the tectonic plates, the crust, to move back and forth, the lithosphere. So it's made of solid rock like putty, flows very slowly. It flows at the same rate that your fingernails grow. So obviously that's pretty slow. And we've already talked about this and how the crust, which we now know is called the lithosphere, is broken into pieces, and those are called tectonic plates, and they are moved because of what's happening in the mantle called convection currents. And this is a good diagram. You can pause and check it out. So look at these. What does this tell you about the temperature of the earth? As you go toward the center, the temperature increases. And you can pause and see that. And I'm about to run out of time. So you can see temperature